Hi there. For this video, you can title it Unit 3, Lesson 2. You're going to need a few things besides your notebook that you are going to take notes on. You need this problem-solving thinking guide, this yellow piece of paper from our exit ticket in class, and then you also need your student copy of today's lesson that has lots of words on it with our problem set. We're going to be looking at the exit ticket today for our problem. Also on the screen, I have a copy of the exit ticket question on the screen with my annotations. So if you have not annotated the question or you have not filled out this problem-solving thinking guide, this yellow piece of paper, then you are going to pause the video here to fill that out and then come back to it. I'll show you my annotations. If you look on the screen here, I have different things underlined and circled. Whatever you're using in nav math, you are also going to use here. For example, I underlined every number and the quantity that was involved. And then anytime there was a word that meant a math symbol in my head, I wrote the math symbol down. So for example, it says if you want to make a profit of at least $1,000 each day, in my head, the words at least mean the profit has to be greater than or equal to this amount. Okay, and then you have to figure out the minimum number of people that must ride the roller coaster. And so there are different things that is going on. We're either figuring out how much it costs to maintain this roller coaster or how much it costs for people to ride the roller coaster. But this is my first go around at reading the problem. I'm going to look at the problem more closely when I fill out my problem solving thinking guide. So that yellow piece of paper, this is not yellow on my screen, but it is what the paper is. So here's an example of what I wrote. You can compare it to what you wrote. I talked about the context of the problem, the name of the roller coaster, that it costs money to run, but also costs money to ride the roller coaster, and we want to make a profit. In the find, we're trying to find the number of people to make a profit, and the profit has to be at least $1,000. At least $1,000. Okay, so what information do we already know? And then we're going to list important quantities and units. Well, it costs $200 a day to rent, and it costs $65 a day to maintain, which means that also is a cost value. So we're not making money from that $65, we have to spend that $65. So that's the kind of information, that's the information that's going into this box here. So looking back at the quantities you listed, what do they have to do with the problem? This is where you would talk about if it costs $200, that means that we don't earn, that costs us $200 to maintain this ride. Just like we need to make more than $200 to make a profit, and we need to make more than $65 to make a profit, because $65 is a cost and $200 is a cost. And then how are we going to make a profit? I wrote here, to make money, we need to charge people each $6. So that's how you use this box. That's a way of using this bottom left-hand box. In the bottom right-hand box, it says, is there any more information that we need before we need to begin solving? I was like, I don't know what the 5.5 days mean in this problem. So if that comes up, maybe. But these are questions where if you're like, what color is the Ferris wheel? Or how many people? Or what type of roller coaster problem is there an age restriction? Is there a height restriction? Those kind of questions, if you are finding that you're thinking about those questions when you're reading these problems, document them here just to get them documented. Okay, back to the video. That was just a recap of, I'm on that app, of the video, but now we are going to actually do some solving of the video, or of the question. Okay, so we need to make an equation here that is part of what this whole problem is about. We talked about the problem. This is what we figured out from our paper, is that we need to make money, and we need to make more than $200 and more than $65 and more than $1,000, because if nobody rode the ride, if 0 people rode on our ride, it would cost us $200 plus $65. But we don't want a negative number. We want $1,000 or more than $1,000. So our profit is going to come in is when we make the money we make is more than the money we have to spend. So that's what we have to think about. So how do we figure out how much money we're going to make? Well, we're going to have $6 times the number of people. So we need to charge maybe 100 people or 200 people. We don't know yet. But every day, a certain number of people are going to come in. But we have to think about what is it going to cost us. Well, we have to subtract away the $200 it cost for the rental, and then we have to subtract away the $65 it cost for the safety inspection each day. So all of this, our money coming in, this is our money coming in, what we're charging people. This is the money we're making. It has to be greater than or equal to 1,000. And if you're wondering why it's 1,000, it's because in the problem, they don't want you to just make a profit. They don't want you to break even so you earn $0. You need to make at least $1,000 a day in order to be at that carnival and to be a successful business person. So how we're going to do this is I made an inequality here. Again, 6p is the amount of money coming in to our roller coaster. We have to take away things like the $200 for the rental and the $65 for the safety inspection, and all of that altogether, which means equals, has to be greater than or equal to 1,000. So, okay. So what we're going to do is we can solve this part now. So we have 6p minus. I'm going to combine these. Negative 200 plus negative 65 is negative 265. And then I'm going to isolate my variable for p by adding 265 on both sides, drawing a big bar. 6p is going to be greater than or equal to 1,265. So if I divide both sides by 6, my number of people needs to be greater than or equal to, I did it in my calculator already, 210.83 people. Oh, 0.83 of a person does not really work. So to break even, to have at least $1,000 or more, we actually need to round up because these are in whole people. Round up because we're in people. So we actually need more than 211 people to ride the ride in order to make more than $1,000. So that's the math portion of it. But again, I want you to think about how did writing the math portion relate to the breakdown you did with this piece of paper. So my idea is that this piece of paper, you will be able to go through enough information where you can think about your equation here and decide if it makes sense. Does it make sense in the context of the problem? Okay. I'm going to pause right here. We're going to do a couple of problems with the rearranging formulas, and then so take a look at your notes, summarize what you need to do. We have another part of this video coming up. The next part of this video, you need to title it Rearranging Formulas. We need more practice on this. That's why it's in this video. We are going to take a look at each formula, and we are going to solve for a certain variable. If you notice, there's more than one variable in each equation, so we have to isolate the variable that they ask us to isolate in the problem. Let's take example 5, or number 5 on this. It says number 5 because it's from the classwork, but you don't have to put that number 5. Solve for x. Well, a lot of you see this and you immediately distribute, which is not a bad idea. 2x minus 8 is equal to 3q plus, q times r. Here's where you guys are like, I don't know. So QRS. So we're going to do QR. I just put in alphabetical order. But so far, so good. We need to isolate x, so we're going to move everything that is not part of this term to x to the other side. That means I'm going to add 8 to both sides. 8 does not have a like term, so I'm not going to line it up with anything. So I'm going to end up getting 2x is equal to 3q plus qr plus 8. And how this is going to work now is to isolate x, we have to divide both sides by 2. Dividing both sides by 2. So x is equal to 3q plus qr plus 8 is equal to 2. Looks very strange. It looks very strange, but we are doing exactly what we need to do, and that is isolating our x variable. Solve for x, our x is equal to something. Great. For number 6, we're going to solve for s. So a is already solved for, but we need to isolate s. Well, it's trapped because it says s squared. So to undo a square, take the square root, which I know you've done in nav math, but we're going to try it right here. So you're going to take the square root of s squared, and what you do to one side, you have to do the other side. So you're going to get plus or minus a is equal to s. And that's it. Not too bad. It looks kind of weird because of these square roots, but this way you have isolated s. 2 more problems. Change a different color. Da, 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 da. Okay, we are going to solve for h. H is here. We need to move everything that is not h over. So everything is separated by multiplication on this problem. So we are going to, I would love if my pen would work. I don't know why it's a link. Oh, I know why it's a link. Okay, it's weird. So all this, I'm going to rewrite it. Oh, v is equal to 3.14 r squared h. So this is all multiplied. So to isolate h, because everything is multiplied by h, we need to divide to undo what is multiplied. So if this is h times 3.14, to undo that, we need to divide by 3.14. So v over 3.14. This is just pi. I thought it'd be confusing if I wrote pi, so I just wrote a decimal. R squared times h. Okay, so now we have h times r squared. So to undo this, we need to, instead of times r squared, we're going to divide by r squared. Oh no, there's already a divide over here. So what do? Another way to think of this, h, is we're going to do 1 over r squared, because this is like dividing, except we're multiplying. So if we multiplied by this value here, then I wonder if it'll work if I copy and paste. But I need to also write the same thing on this side. That's my multiplication property of equality. So multiplying my fractions, my numerators together, and my denominators together, I have this value here. Looks very strange, but it looks great to me. It looks strange to you maybe, but it looks great to me. Okay, last problem. I'll try to make it really quick since we're on like minute 13. Solve for y. Okay, we can do that. Y is this guy over, I have to rewrite this. ax plus by is equal to c. We're going to solve for y. So anything that's not attached to y, we need to move over to the other side. So we're going to subtract ax. Looks very weird, I know. You're going to have to get used to it. Equals c minus ax. Now, this left side, to isolate y, we have y times b. So how do we undo times b? We divide by b on both sides. Divide. So then y would equal to c minus ax over b. Now that you know this, you can go help out anyone else at the school in their math and science classes with their algebra. Take a look at their homework, see if you can solve for a variable that they need. You can go help people. Summarize in your notes. Summarize. And then I will see you either tomorrow or the next day. Bye.